Hi friends! This series of videos are about program development cycle. I'll introduce the stages and important concepts of it. Plus, I'll give examples and practices for you to learn how to implement the stages. If you're ready, let's start. You want to write a program which can account, track your expense or income. And you want some functions, such as calculating your remaining money and the ratio of your spendings. When you are designing the function of calculating remaining money of a certain month, you may think, I might just focus on the income and expense of a month. Then, if I want to calculate the remaining money, I need to know the sum of the income and expense. Then, subtract the expense from income. These steps are called analysis. After having ideas of how the steps of calculating remaining money might be, you may think, how can I calculate the sum of income and expense? First, I might need a variable to store the sum. Then, I need to add the income or expense one by one to the variable. The process of thinking how the program should be developed is called design. After designing how the program should be developed, what should we do? You start coding. So the next step is called coding for sure. After coding, to ensure many situations can be managed by the program, you should run the program with different sets of test data. For example, will the remaining money be a negative number? Or what the program will output if the income equals to 0. These are the stages you will go through when developing a program, and I will get into more details of each stages in 5 videos. In this video, the first video, I will introduce 2 important concepts in analysis stage. If you're ready, let's start. Navigating with Google Map. You want to go to the nearest McDonald's, and on your Google Map it might be like this and not this, right? Because the terrains and shops on the map aren't important to you. Just the distance and where to turn matters, right? Keeping elements required for the solution and discards any unnecessary details and information called abstraction. So, if you're writing a program to calculate the ratio of your expense and output the top 2 category, which information isn't important? In other words, which information doesn't matter with the problem you're dealing? A, B, or C? This question leaves to you. So now, selecting information which is important is called abstraction. While you're thinking which information is important, you will also think of, how can I break down this problem into smaller parts, which is easier to solve? It's like when a class participates in a cheerleading competition. The class might decompose the mission into smaller parts like select songs, design the moves, practice, etc. These smaller parts are easier to manage and execute. So, back to designing of tracking expense program. You're planning to write a function to calculate the ratio of your expense and output the top 2 category. How will you break down this problem into smaller parts? First, you need to calculate the ratio of each expense category. Then, compare each ratio to know the top 2 category. Okay, here comes a simple question. Can you break down the problem A into smaller parts? Pause the video and think of your own answer. To calculate the ratio of each category, you must know the sum of each expense category and the sum of all expense, right? Then, you divide the sum of each expense category by the sum of all expense. Okay. Analysis and decomposition are two important concepts when you analyze a problem. Now, it's your turn to practice. You are building a basketball machine. The user input of the machine are the money and the shooting. The output is the player's score and time. And there's a sensor near the basket to decide the shot is 2 points or 3 points. If sensor 1 is triggered, it's a 3-point shot. If the sensor 2 is triggered, it's a 2-point shot. We want to design a simple program. If the player put 10 NT dollar, the person can play for 1 minute. If the player put 20 NT dollar, the person can play 2.5 minutes. The player can put at most 20 NT dollar per time. During the game, the machine has to show the countdown of the time and score and calculate the score. Finally, the output the final score right after the game ends. Okay, there's some question. First, above all elements, which are important to your solution, A to F? The second question is, please write down how you can break down this problem into smaller parts, and I'll give you the first smaller problem for you to refer. Okay, please pause the video to finish the practice, and I'll give my answer after you come back. Go! Okay, as for the first answer, which are important to your solution? My answer will be A, B, C, and E. For the D, the ball parts, for the program of the machine, it doesn't matter whether the player throw a ball or not, or the number of the balls. What matters to the score is whether the sensor is triggered or not, right? As for F, number of the player, the number of the player won't affect the program. Just the sensor and time affect the outcome of the game. As for the second question, how to break down this problem into smaller parts, my answer will be, first, the smaller problem will be, determine game time depends on the money. The second smaller problem will be, while counting down, I will do 3 things. First, show the time. Second, calculate the score with sensor. Third, show the score. And my last smaller problem will be end game and output final score. Okay, this is all for the analysis stage. In the next video, I'll introduce some methods used to design a solution and some common and useful methods in algorithm. Please stay tuned and I'll see you in the next video. Bye!